let's look at another example with a few parts about ratios and proportions. This is another thing that I was just doing, going hiking in Colorado and talking with my wife about steep trails, things like that. And so we're hiking on a trail that climbs at a steady pace. So it's the same ratio of elevation gain to horizontal um, as you go through the trail, which is not super common, but let's assume for simplicity that it's very, very steady pace, at least so far. And so far, you've gone 3.5 miles and you've climbed 2,000 feet. Um, and first thing is just a kind of a yes or no or like comparison question. And a trail is considered particularly steep when its grade is over 20%. That would be really steep for a road, like usually illegally steep or like four-wheel drive dirt road steep. But for a trail, it's just quite steep. And the question is how does this trail compare to that standard? And one reason I wanted to do this example is we've got a very common thing where we want to set up a ratio, pretty straightforward in principle, but we've got a unit collision here, which is really common, right? Um, and then we've also got a comparison to a percent. So we want to calculate the ratio, and it would be 2,000 feet of vertical gain over 3.5 miles. And that's kind of awkward because the units don't cancel out nicely. 20%, that's just equal to the number 0.2, right? Percent just means another way to write just some standard number. 20% just is 20 over 100 or 0.2. And I want to compare this number to 0.2, but I've got to figure it out in a way where those units just perfectly cancel out. I would like it to be feet over feet or miles over miles. Okay, so a couple ways to do that, but probably a simple way is to just not do this directly, but do the unit conversion first. It's not the most clever way to do it, but it's probably the simplest way to do it. Just say, I don't like miles. And then this is something they focus on a lot in science class. We tend to write it in a slightly different way in math class. To do a unit conversion, we would just take that same number, and then what we're going to do, the way I like to always say this, is we're not changing that number at all. It's absolutely crazy to change this number. It's 3.5 miles. It's what it is. I can't just pretend it's longer or shorter than it is, but I need to write it in a different unit. So I'm going to multiply it by something. And if I agree that I can't actually be changing the number, I have to multiply it by 1 written in a clever way. And a clever way to write the number 1 in this case is to say, I know, and this is something you really should have memorized, somebody living in the United States, that 1 mile has 5,280 feet. And so 5,280 feet on the numerator, 1 mile on the denominator is just the number 1 written in a clever way. But notice what cancels. The miles cancel. Okay. And then it's going to come out to feet. And so that's going to be 3.5 times 5,280 feet. And let's get that number, 18,480. Okay. So now now the units are compatible. And so the grade, which is the rise over run, the vertical rise, and then we often use the word run to talk about how far something goes horizontally. This is also called the slope. This is an incredibly important concept. Mathematically, you've seen it a little bit with straight lines. And so that's going to be 2,000 feet over 18,480 feet. Those cancel. And what do we get? Let's compute that. Okay. And that's 0.108. And I don't need the rest of the precision there. And if I like percent, I just move the decimal place over and say that's about 11%. So this is moderately steep, but it is definitely not as steep as that 20% that I was using as a comparison. So it's about half as steep. So this trail, so far at least, is about half as steep as the 20% standard. Okay, so that's just, remember, that's not a proportion really, because it doesn't have to solve an equation. It's just calculating a ratio, but with the very, very common complication of having a unit incompatibility we had to fix. So here's something where we would actually have a proportion. Suppose the grade continues as before. You think, you haven't checked the map. You're like, I think it just is going to continue at the same steepness. And what I happen to know is the elevation that I need to get to. I need to get another 1,200 feet higher in elevation. And I want to know how many more miles do I have to go horizontally. Okay. So if that grade continues as before, then I've got an unknown. How many more miles do I need to go based on the elevation? So again, there's a couple ways to do it. I'm going to show you how we would do it with keeping the feet and the miles. To get this number here, we really did have to kind of convert something. So it's just feet versus feet. But I can work with feet and miles and these inconsistent units as long as I'm careful. So I'm going to go back to what I had with feet per miles. There's nothing absolutely wrong with feet per mile. Okay, that's the known grade we've had. And if we assume that that continues, and I want to get another 1,200 feet, and I want to know how many miles, that's where I would put the unknown here. Okay, so now I cross multiply, and I'm going to get 2,000x equals 3.5 times 1,200. And the units, I don't really have to write the units here because it's going to come out. I know that x is measured in miles, and so when I solve this, I know that that's going to be measured in miles. And so I can divide by 2,000. And 3.5 times 1,200, that's 4,200. Some of these I can do in my head, over 2,000. And that's actually not too hard, 2.1, and that's miles. Okay. So I had a proportion, an equality of ratios. It had some funky units, but the units were consistent on both sides. I did the cross multiplication and didn't show you the details of that, but we're going to get really used to that. Then I did one more division, and then I recognized, oh, I've got a number in miles. So if the grade does continue as before, the same kind of steepness, not getting less steep or more steep, I expect to be just going a little over 2 miles more, which is a really nice thing to know. If you're on a hike and you want to know, when is this going to be done? How tired am I going to get? This is really useful information. Let's just do one more variation on that. Okay. Now I actually look at the trail. I look at the map and I say, oh, it's not 2.1 miles. Okay, that means this prediction, which was based on the assumption that the grade continues as before, that's not true, because then it would be 2.1. It's only 1.3 miles. The question is, two questions. Is the rest of the trail steeper or less steep than the first portion? And then the next question is, well, what is the new grade? What is this percentage number? I mean, we can go back and compare to that 20%, which is supposed to be kind of a scary steep trail. So hopefully you can see that if I'm going to take less horizontal to go the same amount of vertical, that's going to be steeper. It's kind of good news that I don't have as many miles to go, but if this 1,200 feet, if I still have to go 1,200 feet up, I still have to go that vertical, and so I'm going to do it in less horizontal. That's going to be steeper than I expected. Okay, so it looks steeper, and then we can calculate the new grade just by going back to the same kind of calculation we did before. So it's 1,200 feet over 1.3 miles. Okay, let me go ahead and show you the alternate way of doing this. You can set up the ratio. The first way I showed is before we even set up the ratio, we were a little scared of mixing units, and we just converted miles to feet. What we can do here is we can just go ahead and multiply by that same kind of conversion factor to change miles to feet. I have to be a little careful here, though. I want the miles to cancel. So once again, the universal principle is never multiply by anything that's not the number 1 in disguise. But you also want to do it so that the unit you don't want, here I don't want miles, is going to cancel out. So that's why the mile has to be on top here. Now notice the feet are going to cancel out as well, and that's cool because what we expect is just a pure number. A grade, that slope, is just going to be a pure number, and then we'll convert it to a percent. And so all the units are going to cancel out, and I'm just going to rewrite it so that the computer can calculate this for us. And okay, 0.174, or 17.5%. So if we think of that 20% as like, whoa, that's a steep trail, this is getting much closer to that than the original grade that we had had.